This video looks at using and storing extra point attributes in TerraScan. An LAS file format has a number of standard attributes, such as x, y, z of a point, timestamp of a point, classification class of a point, intensity value, and so on. And an LAS file can store extra attributes. Many of those are something TerraScan understands. TerraScan has specific code for handling amplitude values, or making use of reliability, or making use of normal vector information. So these are known extra attributes, something TerraScan knows about, but which go outside the standard LAS point record attributes. An LAS file can also store attributes TerraScan has no specific code for. These I would call unknown attributes. These may be something that a hardware manufacturer software stores. And TerraScan will only see a name and see that there is something which is stored as 1 byte, or stored as a float value, or stored as a 32-bit integer. And TerraScan can read those from an LAS 1.2 to 1.4 file, an LAZ 1.2 to 1.4, or a fast binary file. Keep those unknown extra attributes and write those to a file of the same formats. And we can do classification, we can color the points by extra attributes, and so on. And in this video we look at how to do that in TerraScan. You can classify points based on an extra attribute. You select the attribute to use and you specify a minimum and maximum value. You can display points colored by an extra attribute. So you create a coloring scheme listing the colors to use. If you want to store extra attributes in a project, your project definition needs to list the extra attributes to store. The easiest way to do it is to use read file and select an example file which has all the attributes in it. For working with macros, we need somehow to define all of the extra attributes that we may use. And in user settings, there's an extra attributes category where you can build a list of extra attributes, which then can be selected in the different macro actions. Again, the easiest way to create this list is to use Add from File button and select an example file. This video shows a live demo. The data is courtesy of Teledyne Optech, bathymetric LiDAR data with 20 additional point attributes. First, I'm going to read some points from files which have unknown extra attributes. In the list, the first ones are known attributes, and in quotation marks, I have unknown extra attributes. Altogether 20 of those in these input files. The software has read in all the unknown extra attributes together with the known point attributes. First, I'm going to show you the scan pattern. I color points by time. We only look at one scanner, so the display is simpler to understand. And when we zoom in, we see that it is an elliptical scan pattern. I will use inspect point to look at some of the unknown attributes. I want to see the values of horizontal uncertainty and of nadir angle. When I move the mouse, I see the values for the point closest to the mouse. Those are now displayed with scientific notation. The software doesn't really know if the values are big or small, so it doesn't know how many decimals it should use. I can color points by an extra attribute, so I selected off nadir angle. I have created a color scheme, and then I display the points colored by this unknown attribute. Red means bigger angle from a vertical, and blue means smallest angle from vertical. As it is an elliptical scan pattern, all the values are much bigger than 0. Now I'm looking at the histogram of nadir angle to get an understanding how the values vary. And I can classify points by an extra attribute. So I'm going to classify those points into steep angle class, where off nadir angle is bigger than 22. Now I will look at all the scanners and only the steep angle class. And that's the points which had a value bigger than 22 in this unknown extra attribute called off nadir angle. In TerraScan settings, I can create a list of extra attributes that I'm likely to use, so that I can create macros that use those attributes. I select an example file, that's the easy way to create the list, and I store this list as extra bathymetric file. In here I can specify how many decimal values I want to see for the different attributes. When that definition is done, if I use inspect point again, I will now see the values displayed in a nicer way with a selected number of decimals. And when I have the list defined in the user settings, then I can work on macros. If I do an operation which modifies extra attribute values, such as clear attribute, I can select an attribute from a list, the list coming from the user settings. To store the extra attributes into my project, I need to add a list of extra attributes to my project definition. The easiest way to do it is to read those from an example file. And I save the project. Then I'll import my raw point cloud files into the project. And then I have a project which is storing all of the point attributes that I had in the incoming files. If I open a block, then I can do all the same things, color the points by an extra attribute or classify points by an extra attribute. And I can do classification actions in a macro. So I have a macro which has just one step, classifies by an extra attribute. If off-nadir angle is bigger than 22, we classify the point to steep angle class. And I'm going to run this macro on the project. And now if I open the block, then I have the classification result in there based on off-nadir angle extra attribute. Thank you for watching.